Hi folks. Right, so it's going to be quite a brief how-to today because actually I think even if you guys aren't sure how to do this yet, after about my first 7 words of explanation you'll have it and you'll be flying with it, okay? I don't think you're going to take much teaching really with this, to be quite honest. I think you guys are going to pick it up really quickly. So the first thing we're going to look at is sector area. So just to remind yourselves, a sector is a part of a circle, a bit like a slice of pie, not to be confused with a segment, which is kind of like this part here. Looks like, well, the shape of a kind of a segment of orange, okay? Not to be confused. Okay, so to find the area of a sector, the first thing we're going to do is consider the area of the circle. Okay, and these are going to be quite generic today. I'm not going to give measurements on them. Area is pi r squared. Okay, it's the area of the circle. Now we only want a certain part of that, and we have to consider it as a fraction. Okay, and that's what we're going to do here. We need to find a fraction of the total area. So you're going to find out how many degrees of your circle the sector takes up. So here we should have 120 degrees. Okay, so this is taking up 120 degrees out of 360. Okay, so out of 360. So to calculate the area of the segment, all you're going to do is find, in this instance, 120 out of 360 multiplied by the area of the circle, so pi r squared. Okay, and if you want that in more general terms, what we'll write is, I'll get this other colour just so it pops out for more general. We'll call this theta, okay, the angle. So I'm trying to think where I can write this. I'm just going to write it over here actually underneath sector area. So it might be worth writing this down as a general equation to calculate this, okay, or general formula by now. So we've got sector area is pi r squared multiplied by theta over 360. Okay, so what you end up with here is a fraction. This one actually simplifies down to 1/3 of pi r squared. Okay, and that is how much of the area it would be. Okay, so you should be fine with that one. Now arc length, I'm just going to fold this up because it doesn't really fit on particularly well. Arc length is a very similar theory, really, very similar theory. So we've got arc length, so our arc, I've drawn an arc in here as an example, okay? So it's just a part along the side of the circle, a part of the edge, a part of the circumference, which is actually perhaps quite a useful word to use here. Okay, so the first thing we need to do is to calculate the entire circumference. Okay, so the entire circumference we've got, let's come down here with this, can we see? I'm going to write it in the middle. Circumference equals, depends on your favourite really way to write this. I mean, most people call it pi d. Some people write 2 pi r. It's the same thing because d is 2r. It's just however you prefer to look at that. So pi multiplied by diameter. Okay, so that's for the entire circle. So of course we only want a portion, we only want a fraction of it. So we're going to just connect our arc to the centre of the circle. And as we did before, we're going to be interested in this angle here, okay? So I'm not even going to measure it this time, I'm just going to call it theta. And we're going to be doing the arc length equals theta over 360, because there's 360 degrees in total, multiplied by pi d. Okay, I do imagine, guys, that as soon as I started talking or drawing on these, that you probably kind of went, oh yeah, I can see it now. So I'm just going to leave it at that. If you've got any more questions, or if you do need any more explanation, please do get in touch and I can certainly sort that out for you. Don't worry if you do need more explanation, it's absolutely fine, just let me know. I just don't want you to sit here for 20 minutes watching a video which only needed to take 5. Okay folks, thanks.